Alright, let's look at the homework 5.2, 5.3, problem number 8. Alright, so let's use substitution to evaluate this indefinite integral. Alright, so let's do that. Let's see here. Substitution, as usual, it's going to be the expression inside the square root here. So I'm going to let u be 8x plus 7. Alright, then we can just do the usual drills. So take the derivative of u with respect to x. We get 8. And then we take the reciprocal of both sides so that the dx comes on top. So dx over du is equal to 1 over 8. Then we can multiply through by du so that dx is equal to du over 8. Alright, so let's rewrite this integral here. Alright, so we have a 9 on top, so I'm going to keep it as it is. And over. Alright, so we decided to call this guy ax plus 7 u. So we're going to have square root of u on the denominator. So you have a square root of u. Alright, and the dx is equivalent to here. We found out that du over 8. So we can put this guy right in here. So we have du over 8. Alright, then we're going to do a little bit of cleaning up. Alright, so since you have a number, 9 over 8. So here you have a 9 over 8. Alright, this is just a constant, so we can kick it out of the integral here. So we're going to have a 9 over 8 outside. Alright, then we have a 1 over square root of u. So we can rewrite it as u to the, since u is in the denominator, so it's a negative power. Alright, square root is equivalent to 1/2 power, so it's going to be negative 1/2 power. Alright, with respect to u, so du is still there. Alright, then this is going to be a power rule. Alright, 9 over 8, it's just a constant sitting in front. Alright, add 1 to the power, so you're going to have u to the positive 1/2. Alright, and divided by 1/2. Or you can write it as multiply by 2, same thing, plus some constant c. Right? Then we can do a little bit of cleaning up here. So you have 8 times 1/2 leaves you 4 on the bottom. So we have a 9 over 4. Then this is going to be square root of u. So 1/2 power is a square root. And remember that the u is originally 8x plus 7 plus some constant c. Right? So let's type it in. Alright, so we have 9 over 4. And we have a square root of 8x plus 7 and plus some constant c. Alright, let's check the answer. Alright, I came back and looks like we got the correct answer. Alright, let's do the checking. Alright, so let's see if we can take the derivative of this to get the integrand there. Alright, so here's the check. So check here. Alright, so we can take the derivative. So I'm going to just write it as a d over dx of this, the answer we have. So you have a 9 over 4. Alright, so I'm going to actually, it's easier to take the derivative, so I'm going to write it as a 1/2 power instead of square root. So you have 8x plus 7 to the 1/2 power plus some constant c. Alright. If you take the derivative, you see that the 9/4 is just simply a constant multiple. Alright, then we just put it there. Alright, so derivative of that is put 1/2 in front and keep the inside expression, which is 8x plus 7 as it is, and subtract 1 from the power, so it's going to be a negative 1/2. Then you would have to multiply by derivative inside, which is 8. And the derivative of c is 0, so I'm not going to write anything down there. All right, then we can clean up a bit here. You have 4 times 2 is 8, and there's an 8 on top, so you can cancel that. So we end up getting, this is going to be equal to, right? So you have a 9 on top. Maybe I should circle that so that I don't miss anything here. All right, then since you have a negative power here, so I'm going to put 8x plus 7 on the bottom. So I took care of this guy, and with a negative power. All right, then there's 1/2 power, so, which is equivalent to square root, so you have that. All right. Then you can see that we have exactly the same expression as the integrand here. All right, so this verifies that we have the correct antiderivative. All right, that's it. I hope that this was clear.